Okay, in this problem we're trying to solve a vector differential equation here, an initial condition. So we have r of t, and here's r prime of t, has these components. So if we think of r of t as being this x of t, y of t, z of t, then this differential equation becomes 3. I'm going to have dx dt should be sine of 9t, dy dt should be sine of 4t, and dz dt should be 5t. So that's for the differential part. And then for the initial conditions, we're going to have x of 0 equals 5, y of 0 equals 6, and z of 0 equals 8. And so essentially we get these 3 different differential equation problems and that we have to solve. So this first one, if I integrate sine of 9t, I'm going to have x of t is going to be negative 1/9 cosine of 9t plus c. But x of 0 equals 5. So my x of 0 here is negative 1/9 plus c, because cosine of 0 is 1. We want this to be 5. So that means that c is going to be 5 plus a ninth, or 46 over 9. So my x of t is negative 1/9 cosine 9t plus 46 over 9. So this is a little 6 here. Okay. Then, likewise, I can solve and get y of t here. Right? Instead of 9, I have 4, and my y of 0 is 6. So I'm going to actually just get my y of t to be negative 1/4 cosine of 4t plus 25 over 4. And then finally we want to get what z of t is. So I go back up here, my dz dt is 5, and z of 0 is 8. So I'm going to integrate there. I'm going to have c of t is going to be 5/2 t squared plus some constant. But we want z of 0 should be 8. So our z of t is going to be 5/2 t squared plus 8. Okay, so now I have my x of t, y of t, z of t, and I just write it as a vector now. So this last part is just writing it as a vector here. So remember, my r of t is going to be, I'm going to have a negative 1/9 cosine 9t plus 46 over 9, comma, negative 1/4 cosine of 4t plus 25 over 4, comma, 5/2 t squared plus 8. And so this is my solution. And then I can check this. I can take the derivative here. I can take the derivative here and see what I get. And also I can verify that r of 0 is this 5, 6, 8.